This is your first reading for the Earthquakes and Mountains module. Forces within Earth. Stress and strain. Most earthquakes are the result of movement of Earth's crust produced by plate tectonics. As a whole, tectonic plates tend to move very slowly. Along the boundaries between two plates, rocks in the crust often resist movement. Over time, stress builds up. Stress is the total force acting on crustal rocks per unit of area. When stress overcomes the strength of the rocks involved, movement occurs along fractures in the rocks. The vibrations caused by this sudden movement are felt as an earthquake. The characteristics of earthquakes are determined by the orientation and magnitude of stress applied to rocks and by the strength of the rocks involved. Pause and go answer questions 1 and 2 in your science notebook. Faults. Crustal rocks fail when stresses exceed the strength of the rocks. The resulting movement occurs along a weak region in the crustal rock called a fault. A fault is any fracture or system of fractures along which Earth moves. The photo shows the San Andreas Fault. The surface along which the movement takes place is called the fault plane. The orientation of the fault plane can vary from neatly horizontal to almost vertical. The movement along a fault results in earthquakes. Type of fault. Reverse. Type of movement. Compression causes vertical movement upward along a fault plane. You're filling this in the table in your notebook. Then there is the normal fault. This type of movement is tension, causes vertical movement downward along a fault plane. So here it dropped down as opposed to being pushed up. The last type of fault is a strike-slip fault. Here shear causes horizontal movement along a fault plane. They move side by side. Pause and go answer question number 3 in your science notebook. Earthquake waves. Sandpaper-covered blocks rubbing against each other can model the movement of irregular surfaces that cause rocks to snag and lock. As stress continues to build in these rocks, they undergo elastic deformation. Beyond the elastic limit, they are permanently deformed. At some point after that, the rocks slip or crumble, and an earthquake occurs. The vibrations of the ground produced during an earthquake are called seismic waves. Every earthquake generates 3 types of seismic waves: primary waves, secondary waves, and surface waves. Primary waves, also referred to as P waves. Primary waves squeeze and push rocks in the direction along which the waves are traveling, as shown in the animation below. Note how a volume of rock, represented by the rectangles in the animation, changes length as a P wave passes through it. The compressional movement of P waves is similar to the movement along a slinky. If the coil is tugged and released quickly, the vibration passes through the length of the coil, parallel to the direction of the initial tug. Secondary waves. Secondary waves, also called S waves, are named with respect to their arrival time. They are slower than P waves, so they are the second set of waves to be felt. S waves have a motion that causes rocks to move perpendicular to the direction of the waves, as illustrated in the animation below. The movement of S waves is similar to the movement of a jump rope that is jerked up and down at one end. The waves travel vertically to the other end of the jump rope. Pause and go answer questions 4 and 5 in your science notebook. Generation of seismic waves. The first body waves generated by an earthquake spread out from the point of failure of crustal rocks. The point of failure, where the waves originate, is called the focus of the earthquake. The focus is usually several kilometers below Earth's surface. Depending on the depth of the focus, an earthquake is classified as either a shallow focus, mid-focus, or deep focus earthquake. The point on Earth's surface directly above the focus is the epicenter, as shown in the diagram. Surface waves originate at the epicenter and spread out. In our diagram, we can see the focus way down in the Earth. Waves come out of that focus, and this is all happening at the fault. And directly above the focus on the surface is the epicenter. And seismic waves continue through all of this. And the arrows are showing the direction the waves are traveling. Pause and go answer question number 6 in your science notebook. And that is it for this first bit of notes. You can look for the next video to answer the remaining questions.